Hi. Now for the last part of this question, we're asked to plot the point p bar t bar, the mean of p and the mean of t, and draw the regression line on the scatter diagram. So the mean of p, the mean of t, we worked out in the previous part. We just had to work out the sum of p, divide it by 6 to get the mean of p, and similarly sum of t divided by 6 to get the mean of t. Well, I'll bring those results up again that we worked out earlier. So sigma p was 93, sigma t was 34, and when you divided those values by 6 you ended up with the mean of p being 15.5 and the mean of t being 5.6 recurring. And I plotted the point on the grid, as you can see here in green. Now we've got to go on to draw the regression line on the scatter diagram, and we also worked that out in the previous part. We found out that the equation of it was t equals 0.741 plus 0.318p, and to draw this line on the scatter diagram, all I did was just take a point p. I chose p to be equal to 30, and when I substituted it in, I plotted the point that we got, okay, the value of t, which turned out to be 10.281. So that's that point up there. I know the graph, the regression line, always goes through the mean of your p and t values, so I knew it had to go through that. I also wanted to just check where it would cross the t-axis, so I just put p equals 0 in, and I've got 0.741, so I tried to plot that point there and then just join them up. Alright, so I had 3 points, okay, as far apart as I could get, just so that I could draw a reasonable line through them. Now in the last part, we're told that the scientist reviews similar studies and finds that pollutant levels above 16 are likely to result in the death of a chick soon after hatching. And we've got to estimate the minimum thinning of the shell that is likely to result in the death of a chick. So to do this, we're looking for when p is equal to 16. So I'm going to substitute p equals to 16 into this equation. So we'll just put it down here. We'll say that when p equals 16, we can see that t is going to equal 0.741 plus 0.318 multiplied by p, which is 16. And if we work this out, you find you get 5.82 and so on. So if we round this, say, to 1 decimal place, it's going to be 5.8 to 1 dp. Alternatively, I suppose I could just look up on my graph where 16 is for p, go up to the line and then across, but it's not as accurate, okay? So I feel that it's a good idea just to substitute your value into your equation up here for the regression line. Alright, well I hope that's given you an idea then across this problem, if it caused any difficulty for you.